We are going to start now lecture 6 of chapter 7 class 11th mathematics, permutations and combinations. In our previous lectures we have studied about the fundamental principles of multiplication and addition, and after that we have studied the definition of permutations and the properties related to it. Now we come to the next part, it is combinations. So we are saying, first we look at the definition over here. It is that each of the different groups or selections that can be made out of a given number of things. Now the important part over here is by taking some or all of them at a time irrespective of their arrangements. So this thing now it is important, we are saying it is irrespective of their arrangements, then it is called combination. So we are saying if we are having three persons A, B, C and we want to choose two persons, when we are talking about permutations we were saying it is A, B, B, A, C, C, A, B, C, C, B. These were the permutations because we are talking about the arrangement. This A, B and B, A, these are corresponding to two different arrangements. But now when we are talking about combination, we are saying that we are not interested in the arrangements. So combination basically means that we are not interested in these three parts. We are saying these are the three combinations that we can choose, that combination of A and B, combination of A and C and combination of B and C. So the number of permutations we can have over here it is 6, while that of number of combination that we can have it is 3. Number of combinations we can have it is 3. So this is the basic difference between permutation and a combination. So next result we have is that all combination of 4 persons A, B, C, D taken 2 at a time, it is equal to this. All combination of 4 persons A, B, C, D taken 3 at a time. If we are saying we are having 4 persons A, B, C, D. Now if we are talking about the permutations, we are saying the number of permutations we can have if we are selecting 3 at a time, it is 4p3, that is equal to 4 factorial by 1 factorial, that is equal to 4 factorial. But if we are talking about the combinations, we are saying the possible combinations we can have it is A, B, C, A, B, D, A, C, D and B, C, D. So these 4 are the possible combinations that we have over here. So we have explained over here the difference between the permutations and combinations. So we are saying in combinations only a group is made and the order in which they are arranged, the elements are arranged, it is immaterial. But when we are talking about the permutations, we are saying not only the group is formed, but the arrangement or the order in which they are arranged, it also matters over there. So we use the word arrangements for permutations. We are saying in general what we are doing to distinguish these two, we are saying the arrangement word we are using for the permutations and the word selection we use for the combination. The word selection we use, it is for the combinations. So we are saying if A, B and BA are two different permutations but each represent the same combination, that is combination, we are saying we have selected A and B. When we are talking about arrangement, we are saying A, B and B, A, these are two different arrangements. So in case of combinations, we have this formula, we are saying the number of all combination of n things, we are taking R at a time, we are choosing R things at a time, it is denoted by NCR, or we can write it as CNR. This is just like we were talking about in case of permutation, we were writing it was NPR. Now we are writing the number of combinations we can have it is NCR or we can write it in the form CNR. So both these notation, these are corresponding to the fact that we are selecting R objects out of N objects. So the conditions we have over here, that N should be greater than 0, R should be greater than equal to 0, and N should be greater than equal to R. These are the conditions we have over here. Next is combination of N different objects. We are talking about the formula that we have over here. So we are saying the formula for NCR we have, that is equal to N factorial over R factorial into N minus R factorial. When we are talking about NPR, the formula we have, it is N factorial over N minus R factorial. So if we have to calculate the relation between NPR and NCR, we can see that NPR is equal to NCR into R factorial. This thing we will use to prove this result, and you can also look at this result in this form, that this is the relation between the number of combination and number of permutations of choosing R objects out of N objects. So the proof of this result, it is, we are saying suppose the number of all combinations of N object, we are saying the number of objects we have, that is equal to N. The number of objects we are choosing out of these N objects, we are choosing it is R, and let the number of combinations we have, that is equal to X. So what we have from this is, we are saying that we are choosing R objects out of these N. So if we choose each combination, in each combination the number of objects we have, that is equal to R, and these objects, these can be arranged in R factorial ways in themselves. So it means that if we want to calculate the number of permutations, that will be NPR, and that will be equal to X into R, X into R factorial. This term we are saying X, we have assumed it is the number of combinations that we have made. So the value of X from this we obtain, it is equal to NPR over R factorial, and the value of NPR over R factorial we have, it is N factorial over R factorial into N minus R factorial. This is the formula that we are talking about. This is the number of combinations of selecting R objects out of N objects. Next we have to prove is that NCR is equal to this. So the formula for NCR we have, that is equal to N factorial over R factorial into N minus R factorial. So this is equal to this N factorial, we can write it as N into N minus 1 into N minus 2, so on up to N minus R plus 1 into N minus R factorial divided by R factorial into N minus R factorial. These two terms gets cancelled and we are left with this formula. So we are saying basically the number of terms we are having over here, this is up to R factors, because over here we have first term it is N minus 0, next it is N minus 1, this is N minus 2, so on up to N minus R minus 1. So we are saying this is the first term, this is second term, this is third term. So corresponding to this, look at these terms over here. So this will be the rth term. So we are saying we are having N into N minus 1 into N minus 2, so on up to R factors divided by R factorial. So we have to calculate now the value of 11C4. So we will have it is 11 into 10 into 9 into 8 divided by 4 into 3 into 2 into 1. This gets cancelled. These two terms get cancelled. Then the answer we obtain, it is 330. So the value of 11C4, it is equal to 330. Next we have to prove is that NCN is equal to NC0 is equal to 1. So if we talk about the formula of NCR, it is equal to n factorial over r factorial into n minus r factorial. Now if we substitute n is equal to this, r is equal to n, we will get it is NCN is equal to n factorial over n factorial into n minus n factorial. These two terms gets cancelled. The value of this term, this is equal to 1. So the final answer we obtain, NCN we obtain, it is equal to 1. Similarly, if we substitute r is equal to 0, we will have NC0, that is equal to n factorial over 0 factorial into n minus 0 factorial. Value of 0 factorial is 1 and we are left with is n factorial over n factorial, that is equal to 1. So in both these cases the answer we obtain, it is equal to 1. This next result we have already seen, that NCR is equal to NPR over R factorial. So this result we have already proved. Next is, if NPR is equal to 720 and NCR is equal to 120, we have to find the value of R. So we are using this result over here. So we get 120 is equal to 720 over R factorial. So the value of R factorial we have, that is equal to 6, and this implies us that R is equal to 3. The value of R we have, it is equal to 3. Next is, for 0 is less than equal to R is less than equal to N, we have to prove that NCR, that is equal to NCN minus R. So if we write the formula for this term, it is n factorial over r factorial into n minus r factorial. We can write, when we are talking about this term over here, the value we have, it is n factorial over n minus r factorial into n minus r factorial. Look at this term over here. We are talking about this term. It is n minus r plus r factorial. So this n and n gets cancelled. What we get is, it is n factorial, r factorial and n minus r factorial. So we obtain that both these values, these are equal to each other. Now next we have to calculate is 100C98. So we can write this is equal to 100 factorial over 98 factorial into 2 factorial, that is equal to 100 into 99 by 2, that is equal to 4950. Or what we can do, we can write 100C98 is equal to 100C2, and the answer we know it is, we have to write two terms over here, 100 into 99 divided by 2. So we are getting the same answer over here. Next is, if NCX is equal to NCY and X is not equal to Y, we have to prove that X plus Y is equal to N. So by using this result, we can write this is equal to NCN minus Y. So what we obtain from this is, so this thing implies us that X is equal to Y or X is equal to N minus Y. This implies us X is equal to Y or X plus Y is equal to N. It is being given that X is not equal to Y. This condition is given to us that X is not equal to Y. So we are saying that this thing is not possible. So what we are left with is that X plus Y is equal to N, and this is what we have to prove. Next is if NC18 is equal to NC12, we have to calculate the value of 32Cn. So we are saying NC18 is equal to NC12. So from our previous result, clearly we have these two values, these are not equal to each other. It means the sum of these two values, that should be equal to n. That is equal to n means we are talking about this is value of n we obtain, it is 30. Now what we have to calculate is 32C30, that will be equal to 32C2, that will be equal to 32 into 31 divided by 2, and the answer comes out to be 496. Next is if 10CR is equal to 10CR plus 4, then we have to calculate the value of 5CR. Again, we are having two cases over here. Either R is equal to R plus 4 or R plus 4 should be equal to 10. This condition, this is not possible because it will give us 4 is equal to 0. So this is not possible. So we get 2R is equal to 6. So this implies us R is equal to 3. Now if we substitute this value R is equal to 3 in this equation, we will get it is 5C3 we are calculating. The answer we obtain, this is equal to 5 into 4 into 3 upon 3 factorial. So cancelling these two, we are left with this 2. This is 2. Answer we obtain, it is equal to 10. So the value of this term is equal to 10. Next is let 1 is less than equal to R is less than equal to N. We are talking about this condition. We have to prove that NCR plus NCR minus 1, this is equal to N plus 1CR, and this is called Pascal's rule. Now if we substitute these values over here, we are having the term, it is NCR. So it is n factorial over r factorial into n minus r factorial plus n factorial over r minus 1 factorial into n minus r plus 1 factorial. Now if we multiply the numerator and denominator over here, or in place of this, we are going to write this is equal to, we are taking n factorial common. In the denominator, this term we can write it is r into r minus 1 factorial, and this term we can write it is n minus r factorial, n minus r in plus 1 into n minus r factorial. So we have taken, we are talking about the terms, this n factorial we have taken common, this r minus 1 factorial we are taking common, and this n minus r factorial we have taken common. We are taking these terms common from this. So we are left with, we have taken n minus r factorial common, and we have taken r minus 1 factorial common. So from the first term, we are left with is 1 by r, and from the second term, we are left with is 1 by n minus r plus 1. Now we want the answer in the form n plus 1CR. So to make this term n plus 1, we are talking about this term. If we solve this value, the LCM we will have it is r into n minus r plus 1. In the numerator we will have n minus r plus 1 plus r. These two terms gets cancelled. So what we are left over here is n factorial into n plus 1 divided by, in the denominator we will have r minus 1 factorial into r and n minus r factorial into n minus r plus 1. So if we write these terms over here, we are saying this term, we are saying it is n plus 1 factorial. This term, if we look at this whole term, this is r factorial, and this term we are talking about, it is n minus r plus 1 factorial. So the answer we obtain, this term we are saying this is equal to n plus 1 c r, and this is what we have to prove, that this is n plus 1 c r. Next is, it is given that if 1 is less than equal to r is less than equal to n, we have to prove this result, that n into n minus 1 c r minus 1, that is equal to n minus r plus 1 into n c r minus 1. So we are starting with the left hand side, we are saying it is n into n minus 1 c r minus 1. We have written the value of n minus 1 c r minus 1 over here, this is the value of this term, and these two values, these are this numerator part, it is multiplied over here. So we have obtained the term, it is n into, the term we have obtained, it is n into n minus 1 factorial divided by r minus 1 factorial into n minus r factorial. Now look at this answer that we require, it has the value n minus r plus 1 in the numerator. So we multiply this term with n minus r plus 1 and divide this term with n minus r plus 1. Now if we talk about these two terms, if we talk about these two, the product of these two terms, we will have the product of these two terms, we will have it is n minus r plus 1 factorial, and the product of these two terms, if we look at, the product of these two terms will be n factorial. So the answer we are getting, this is equal to n minus r plus 1 into n factorial divided by r minus 1 factorial into n minus r plus 1 factorial, and this term n factorial over r minus 1 factorial into n minus r plus 1 factorial, we are saying its value is n c r minus 1. This value we are having, it is this term we are saying its value is n c r minus 1, and this result we have written over, that n c r minus 1 over n minus 1 c r minus 1, it is equal to n over n minus r plus 1. So you should remember these results, as many results you will remember, it will be simpler for you to solve the objective type problems. Next is, if n and r, these are two positive integers such that 1 is less than equal to r is less than equal to n, then we have to prove these two results. First is n c r divided by, we are saying n c r divided by n c r minus 1, we have to prove that this is equal to this value. So we are saying, if we write the value of both these terms, we will have it is n factorial over r factorial into n minus r factorial multiplied by, it will be n factorial r minus 1 factorial into n minus r plus 1 factorial. We will have the values in this form, it is factorial over here. So out of these terms, if we look at these terms, this n factorial gets cancelled. This r factorial, we can write it is r into r minus 1 factorial, and this n minus r factorial, we can write it is this term we are saying, this term we can write it is n minus r plus 1 into n minus r factorial. These two terms gets cancelled. So what we are left with is, from the numerator part, this r minus 1 factorial get cancelled. So we are left with is n minus r plus 1, we are talking about this term n minus r plus 1 divided by, in the denominator we are left with is this term r. So we obtain this answer. Next is n c r divided by n minus 1 c r minus 1. So if we divide these values, we will have n factorial over n minus r factorial into r factorial into the terms we will have over here. It is n minus 1 factorial, then it is r minus 1 factorial, then it is n minus 1 minus r plus 1 factorial. Now these two terms gets cancelled, we are left with this n minus r factorial. This term gets cancelled over here. When we cancel these two terms, we are left with this n. We cancel these two terms, we are left with this r. So we are saying the value, the final value that we are left with, it is n by r. So we are saying the value of this term is equal to n by r. So this is our second result that we have proved. Next we have to evaluate the value of 10C3. These are problem based upon these results that we have studied. So 10C3, we know it will be 10 into 9 into 8 divided by 3 factorial, and the value of 3 factorial, we know it is 3 into 2. So this gets cancelled, this gets cancelled, and the answer we are left with is 120. Next is 11C8. We can write this is equal to 11C3. So this is equal to 11 into 10 into 9 divided by 3 factorial. Answer we will have it is 165. Next we have is 50C48. So that is equal to 50C2. That is equal to 50 into 49 divided by 2 factorial. Answer we have it is 1225. This is the answer we obtain in this case. And the last part we have it is 63C63. The answer we have it is 1, because we know that NCN is equal to NC0, that is equal to 1. Next is if NC8 is equal to NC6, we have to calculate the value of NC3. We know that these two values, these are equal. So we will have 8 plus 6 is equal to n. So this is equal to 14. So we have to calculate the value of 14C3, that is equal to 14 into 13 into 12 divided by 3 factorial. These two terms gets cancelled. The answer we obtain it is 364. Now next we have is if the ratio of these three terms that are given to us, this thing we are talking about, the ratio of these three terms, it is 3:4:5. We have to find the value of n and r. So we know the formula that NCR divided by NCR plus 1. The formula we have it is equal to r plus 1 divided by n minus r. So if we substitute these values over here, it is given that the value of NCR, we are talking about these two terms over here, the ratio is given to be 4:5. This ratio is given to be 4:5. So this implies us that 5r plus 5 is equal to 4n minus 4r. So this implies us that 9r minus 4n is equal to minus 5. So this implies us that 4n minus 9r is equal to 5. So this is one equation that we have obtained. Now in this given result, if we replace r by r minus 1, the formula will become NCR minus 1 over NCR, that is equal to r over n minus r plus 1. Now if we look at these two terms, it is NCR minus 1 over NCR. The value of this ratio is given to be 3:4. So the answer we obtain, this is equal to 3/4. So we get 4r is equal to 3n minus 3r plus 3. So this implies us that 7r minus 3n is equal to 3. So we have two equations over here. The first is 4n minus 9r is equal to 5 and second is 7r minus 3n is equal to 3. Now if we solve these two equations, we are talking about these two equations, this is one equation, this is another equation. When we solve these two equations, we get the value of n and r, and these values that we have obtained on solving these two, we are saying we will get n is equal to 62 and r is equal to 27. So these are the two values that are required over here. We have to calculate the value of n and r. Now the next we are given that 2nc3 is 2nc3 is equal to 11:1. So if we write the value of 2nc3, this is 3 over here, it means we are having the value 2n into 2n minus 1 into 2n minus 2 divided by 3 factorial, and the value of nc3 that will be equal to n into n minus 1 into n minus 2 divided by 3 factorial. If we divide both these values, the answer we are getting, it is 2n into 2n minus 1 2 into n minus 1 divided by n into n minus 1 into n minus 2, that is equal to 11:1. So if we look at these conditions, this n gets cancelled, this n minus 1 gets cancelled. So what we obtain from this equation is that 4 into 2n minus 1 divided by n minus 2, that is equal to 11. So on solving this equation, we will obtain the final value of n, that is equal to 6. So we are saying the final value of n we obtain, it is equal to 6. Next is prove that the product of r consecutive positive integers is divisible by r factorial. So suppose we are saying that the consecutive positive integers we are considering over here, the r consecutive positive integers, they are n plus 1, n plus 2, so on up to n plus r. These are the integers we have considered. So their product will be n plus 1 into n plus 2, so on up to n plus r. Now if we multiply and divide this term, both the numerator and denominator, by n factorial, we get this value is equal to, it is n factorial, n plus 1, n plus 2, n plus r. So it is n plus r factorial divided by n factorial, and this value comes out to be r factorial into n plus r factorial divided by r factorial into n plus r minus r factorial. And this term we are saying this is equal to r factorial into n plus r cr, and clearly this value we are saying this is a positive integer. So if this is a positive integer, if this term is a positive integer, so this thing proves that we can write the product of these terms, the consecutive n integers we are talking about, as the product of r factorial into some k. So we are getting that this product, it is divisible by r factorial, and this is what we have to prove. Next is, if npr is equal to npr plus 1 and ncr is equal to ncr minus 1, we have to find the value of n and r. So first condition we are talking about, it is npr is equal to npr plus 1. So this implies us that n factorial over r factorial, n minus r factorial, that is equal to n factorial over n minus r minus 1 factorial. So this n factorial gets cancelled, we are left with this n minus r minus 1 factorial, that is equal to n minus r into n minus r minus 1 factorial. again these two terms gets cancelled. So we get n minus r is equal to 1. This is one equation we are obtaining. Next is NCR is given to be NCR minus 1. And we know that the value of NCR over NCR minus 1, that is equal to n minus r plus 1 over r, and it is given to be equal to 1. So this implies us that n minus r plus 1 is equal to r. So this implies us that n minus 2r is equal to minus 1. So we are obtaining two equations over here. One is n minus r is equal to 1 and second is n minus 2r is equal to minus 1, and on solving these two equations we obtain it is n minus r is equal to 1 and n minus 2r is equal to minus 1. On solving these two equations we will get n is equal to 3 and r is equal to 2. These are the two values that we obtain in this case. Now next we have to prove the result that 2ncn it is equal to this value. So we start with this 2ncn. We are saying this is equal to 2n factorial divided by n factorial into 2n minus n factorial. So this is equal to 2n factorial divided by n factorial square. Now look at this denominator that we have, it is 2n factorial. We can write it is equal to this 2n factorial, we can write it is 2n into 2n minus 1 into 2n minus 2 so on up to 4 into 3 into 2 into 1 divided by n factorial square. Now from this numerator part we are having the term 2n, 2n minus 2, 2n minus 4, these values. We can separate these terms. It is 2n into 2n minus 2 so on up to 4 into 2. These terms we are talking about. And second terms we are having in the form, it is 2n minus 1 into 2n minus 3 so on up to 3 into 1. And in division we have it is n factorial square. So if we look at these terms over here, we are talking about these values. It is 1 into 3 into 2n minus 3 into 2n minus 1. This is this part of the answer. For the remaining term, if we take 2 common from all these terms, we are saying this term we can write it is 2 into 1. This we can write it is 2 into 2. This we can write it is 2 into n minus 1. This term we can write it is 2 into n. So total number of terms we have it is n. So if we take 2 raised to the power n common, we are left with is n into n minus 1 so on up to 2 into 1. And this value we are saying this is equal to n factorial. This n factorial and this 1 n factorial gets cancelled. So the answer we are left with is 2 raised to the power n into 2n minus 1 into 2n minus 3 so on up to 3 into 1 divided by n factorial. So this is the answer we are obtaining over. This is the answer, this is the required answer. Next is prove that 4nc2n is to 4ncn, that is equal to, the ratio of these two terms is equal to this value. So if we write the terms corresponding to both this, it is 4nc2n, so it is 4n factorial divided by 2n factorial square, then it is into, the next terms we will have it is 2n over here, so it is 2n factorial into n factorial square. Now if we look at this term 4n factorial, we are having the value over here, it is 4n into 4n minus 1 into 4n minus 2 so on up to 4 into 3 into 2 into 1. Rest of the terms, all these terms will be there. So we are left in the numerator, it is n factorial square. Now in the denominator we are having the term, it is 2n factorial cube. So we can write it is, in the denominator we are writing it is 2n factorial cube we are having. We can write it is 2n into 2n minus 1 into 2n minus 2, so on up to 4 into 3 into 2 into 1, and it is whole cube over here. Now if we separate the even and odd terms in the numerator and denominator, we will have, from this numerator part we can write it is 4n into 4n minus 2 into 4n minus 4, so on up to 4 into 2 into 4n minus 1 into 4n minus 3, so on up to 3 into 1 n factorial square divided by, in the denominator we will have the terms 2n into 2n minus 2, so on up to 4 into 2, then 2n minus 1 into 2n minus 3, so on up to 3 into 1, and it is whole cube over here. Now look at these terms over here. We can write it is 2 into 1, this is 2 into 2, this is 2 into 2n minus 2, this is 2 into 2n minus 1, and this is 2 into 2n. So these terms we are saying, we can write number of terms we have, it is 2n, so it is 2 raised to the power 2n into, what we are left with is 2n factorial. We are left with is 2n factorial. So if we write power 2 over here, we have over here it is 2n factorial. Now look at these terms over here. Look at these terms. If we write them in power form of 2, we are having 2 raised to the power n common, and we are left with is n factorial, and these terms we are having it is in this form. So what we get from this, that this n factorial gets cancelled with 1n factorial over here, this 2n factorial gets cancelled with this 2n factorial over here, and the terms, it is 2 raised to the power n, and this power 2 is there. We are talking about these two terms. So combining these two terms, what comes out of this bracket, it is 2 raised to the power 2n, this gets cancelled over here. So we are saying this whole term gets cancelled. What we are left with is 1 into 3 into 4n minus 3 into 4n minus 1, this part we are obtaining, and in the denominator we are left with is 1 into 3, so on up to 2n minus 1 square, and this is what we have to prove. This is the result that we have to prove in this case. Next is, if n plus 2c8 is to n minus 2p4, that is equal to 57 is to 16, we have to find the value of n. So if we write these values, we are having n plus 2 factorial divided by 8 factorial into n minus 6 factorial multiplied by, the values we will have it is n minus 2 factorial, and in the numerator we will have it is n minus 6 factorial. It is given to be 57 by 16. So this n minus 6 factorial gets cancelled, and we can write this n plus 2 into n plus 1 into n minus 1 into n minus 2 factorial divided by, the value we have over here, it is 8 factorial into n minus 2 factorial, it is equal to 57 by 16. N minus 2 factorial gets cancelled. So what we are getting over here is that n plus 2 into n plus 1 into n minus 1, that should be equal to 57 by 16 into 8 factorial. 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So this 8 to the 16 gets cancelled. We are left with this, the terms we are having over here, it is 57 into 7 into 6 into 5 into 4 into 3. We require the value of n to be an integer, and we are talking about, we require n plus 1, n plus 2, n plus 3, these values, these are consecutive integers. So if we arrange these values, we factorize this 57. This 57 can be factorized in the form 19 into 3 into 7 into 6 into 5 into 4 into 3. So if we look at this term 19, it means we require one of these numbers is 19. So from other numbers, we require the numbers which are just consecutive numbers like 18 or 20. In this form, we have to construct the numbers. So if we look at these two, it is 5 4s are 20. We can write this is 19 into 20. Then it is 7 3s are 21. We will have 21 over here, and 6 3s are 18. So what we obtain from this is that we are having the numbers in the form, it is 21 into 20 into 19 into 18. So from comparing these two values, we obtain that the value of n we have, it is equal to 19. So this is the required value of n that we have in this case. Now the next question we have is, we have to evaluate the value of this term. So the terms we have over here, it is 47C4 plus, it is summation over here. So if we write the terms corresponding to this summation, we are talking about this summation, we are substituting j is equal to 0. When we substitute j is equal to 0, we will get it is 50C3, then j is equal to 1, it is 49C3, then it is 48C3, and when we substitute 3, it is 47C3. Next we have the second summation, we have it is in this form. Now look at this term over here, it is 56 minus k C53 minus k. We can write this is equal to 56 minus k C, 56 minus k minus 53 plus k. So these two k gets cancelled, we are left with this 3 over here. So we are writing this is equal to 56 minus kc3. Now the values of k, they are varying from 0 to 5. So we are saying that the terms from this second, it is 56 minus kc3, the values of k, they are varying from 0 to 5. So the answers we will have, it is 56c3, 57c3, so on up to plus 51c3. So we can write these terms in the form, we are writing it is 47c4 plus 48c4, it is 48c3, this term we are saying. Next it is 47c3, then it is 48c3, 49c3, so on up to the last term we are having over here, it is 56c3. Look at the value of these two terms. We are applying this formula that NCR, we are saying 47c3 or 4 plus 47c3, the value we will have, it is 48c4. So we are saying that sum of these two terms will be 48c4. Similarly, if we look at these two terms, the sum of these two terms will be 49c4. Sum of these two terms will be 50c4. Likewise, if we continue, in the end we will have 56c4 plus 56c3, and the sum of these two values we will have, it is 57c4. 57C4, and this is the required answer. This is the answer we obtain over here, that the sum of all these values, it is 57C4. Next is prove that the greatest value of 2NCR, where R is varying from 0 to 2n, it is 2NCN. This thing we have to prove. So to prove this result, we are going to find the ratio of 2NCR divided by 2NCR minus 1. And we know that the value of this term is equal to 2n minus r plus 1 divided by r. We are using this formula over here. We have already proved this result. And we are saying this value is equal to this. And this term we can write, this is equal to, this term we can write it is equal to 2n minus 2r plus r plus 1 divided by r. Now this numerator we can say it is 2 into n minus r plus r plus 1. So this numerator part we are saying, this value we are saying it is r. This is, we can write it is r plus 2 times n minus r plus 1 divided by r, and this is greater than 1 because it is being given that 0 is less than equal to r is less than equal to n. So we are having this term r plus 1 over here. So numerator will be greater than r. So we are saying that the ratio of these two terms, it is greater than 1. So we obtain from this that 2NCR minus 1 is less than 2NCR. Now if we put the values of r is equal to 1, 2, 3 in this equation, we will obtain that 2NC0 is less than 2NC1, 2NC1 is less than 2NC2, so on up to 2NCN minus 1 is less than 2NCN. So if we combine all these inequalities, we will have 2NC0 is less than 2NC1 is less than 2NC2 is less than, so on up to 2NCN minus 1 is less than 2NCN. We know that 2NCR, that is equal to 2NC2n minus r. So if we use this result over here, we obtain that 2NC2n is less than 2NC2n minus 1 is less than 2NC2n minus 2 is less than, so on up to 2NCN plus 1 is less than 2NCN. So what we obtain from this is that the greatest value, look at these terms over here, we are saying that 2NC0, 2NC1, 2NC2, 2NCN minus 1, all these values are less than 2NCN. And when we are looking at the terms next, we are looking at the next terms over here, we are talking about 2NC2n, 2NC2n minus 1, 2NC2n minus 2, all these are less than 2NCN. So what, by combining both these results, we obtain that the greatest value we will have out of all these, it is corresponding to the term 2NCN. And this is what we have to prove, that the greatest value we have over here, it is 2NCN. It is when r is equal to